So today we're going to learn another method of solving systems of equations. So far we've done graphing and we've done substitution. And today we're going to learn a third way, which is by a method called elimination. Okay, so I'm going to follow these steps and walk you through the first example here. Now step 1 says rewrite each equation in standard form. Ax plus by equals c. If you look at example A, it is already in this form. We have a 4x plus a 3y and a 2x minus 3y, and that is equal to a constant, which is c. All right, and then it says if necessary, multiply both of the equations by a non-zero number so that the coefficients of a chosen variable in the system are opposite. What the heck does that mean? Well, again, looking at example A, we don't have to do this because it's already done for us. You can see I have a 3y and a negative 3y, which are opposite. All right, so step 2, already done. Then it says add the coefficients. So what I'm doing here is I'm looking at this as a big addition problem. Okay, and I'm going to add straight down. 4x plus 2x is 6x. 3y minus 3y is 0. That is why this method is called elimination, because I just eliminated the y. There are no more y's left. Equal sign. Now I add my constants. 1 plus 5 is 6. Do some algebra to solve for x now. And I get x is equal to 1. All right. Step 4 says find the value of one variable by solving the resulting in step 3. So that's what we just did. And then step 5 says find the value of the second variable by substituting the value in step 4 into either of the original equations. So it does not matter which one you choose. So I'm just going to choose 4x plus 3y equals 1. What I'm going to do is I'm going to take what I got for x and substitute it in for x in this second equation. And it won't let me highlight, so I'm just going to do this. Substitute it in for x. So 4 times 1 plus 3y equals 1. And then finally, I'm just going to do my algebra to solve for what y is going to be equal to. So 4 plus 3y equals 1. Subtract 4. So y is equal to negative 1. And just like all the other methods that we have done, I'm going to write that as an ordered pair. 1, comma, negative 1 is my final answer. Okay, so that one, pretty straightforward because I already had those opposites in the beginning. But if you look at letter B, you'll notice that nothing is opposites, right? I have a 2x and a 3x. Those don't eliminate each other. And I have a negative 3y and a positive 1y. Those do not eliminate each other, okay? This is where step 2 comes in, all right? We have to multiply one of those numbers by a constant so that it cancels something out. So me personally, I'm focusing in on this y here with no coefficient. If I multiply that by 3, it will eliminate the negative 3y. So I'm going to take this entire equation here, and I'm going to multiply it by 3. So I will rewrite that so it looks a little bit better. I'm multiplying this whole thing by 3. All right, so I do that, I get 9x. I do this, and I get 3y equals negative 15. All right, and again, remember we want to set this up like an addition problem. So I'm going to just rewrite that top equation now, right underneath this. All right, and now I do this, and I'm going to make this an addition problem. 9x plus 2x is 11x. Now I have 3y minus 3y eliminates each other. Okay, there's my elimination step. And then negative 15 minus 7 is negative 22. Solve this equation using our awesome algebra skills. And I get x is equal to negative 2. Okay, now I can pick either one of those equations to plug that into to solve for y. And I'm just going to pick this top one, not for any particular reason. All right, so now I'm going to take 2 and plug it in for x up here. So I get 2 times negative 2 minus 3y equals negative 7. Negative 4 minus 3y equals negative 7. Add 4. 3y is equal to negative 3. Last step to solve. And I get y equals 1. So then my final answer is going to be negative 2, comma 1. All right, so sometimes we have to force an elimination by multiplying an equation by something. Okay, so looking at letter C here, you'll notice that nothing eliminates immediately, right? X and 5x do not eliminate. Y and 5y do not eliminate. So what do you think you can do in order to get one of those to eliminate each other? Well, if I look at this x here, if I multiply it by negative 5, then it's going to eliminate the positive 5x. All right, so I'm going to do negative 5 times my first equation. Negative 5x. Actually, I should end my parenthesis over here. Minus 5y equals negative 30. All right, and then I'm just going to rewrite my other equation right below. And then just like the other ones, I am going to turn this into an addition problem. Negative 5 minus 5 eliminates. Negative 5y plus 5y eliminates. Negative 30 plus 30 also eliminates. So I just got 0 is equal to 0. Okay, this is the example where we would have all real numbers. Or remember, we can also say IMS for infinitely many solutions, okay? Or negative infinity to positive infinity. Any of those solutions will work. All right, last one, letter D. All right, again, we have a circumstance where nothing eliminates, right? 2x and 3x don't eliminate each other. Negative 6y minus 9y doesn't eliminate each other. And we also can't use that trick where we look at the one that doesn't have a coefficient, because all of them have coefficients. So this is what I do in this circumstance. We're going to have to multiply both of the equations by something. So if I kind of focus in here on these first coefficients, if I multiply my first equation by 3 and my second equation by a negative 2, notice I just flip-flopped those two things, then one will be a positive 6x, the other will be a negative 6x, and those will eliminate. Okay, so let's do that. 3 times this whole equation. Let's see, I'm going to get 6x minus 18y equals 15. And then I'm going to multiply my bottom equation by negative 2. And remember, they have to be opposites so that they eliminate each other. So here I get negative 6x plus 18y equals negative 4. Okay. And then to make this an addition problem, I just like to stack them on top of each other. Okay, and this becomes an addition problem. So just like we planned it, 6x minus 6x eliminates. And then I get, ooh, I realized I forgot to write a 1 there. Then I get 18, negative 18 plus 18 also eliminates. So I have 0 on this side. And then 15 minus 4 gives me 11. Wah, wah. That's not true, right? So remember when we get weird things that don't make sense, like 0 equals 11, our answer is going to be no solution. All right, and that is how we solve problems doing the elimination method.